Well, hello everyone. Welcome to more algebra homework help. Today we're going to be looking at algebraic elimination. Sometimes people call it the elimination method. And we're going to take a look at the three different levels that this problem is usually presented at. Now in this first level, you just need to add or subtract the two equations. The first thing to notice is that the first equation and the second equation are both in standard form, which looks like ax plus by is equal to c. Once we know that both of the equations are in standard form, I like to look for columns, really. So all the x's are kind of lined up, all the y's are kind of lined up, and all the constants on the other side of the equal sign are also lined up together. I also noticed that in looking at the y's, I've got a negative 5y and a positive 5y, and that's a zero pair. If I added those together, I would just get 0. So I'm going to pretend that this is one big addition problem, and I'm going to add all of the yellow stuff together. That's a 2x and a 3x. They're like terms, so we should be able to combine the coefficients with the same variable. So 2x plus 3x is 5x. Negative 5y plus 5y, we already said that that was a zero pair. So I get a 0, but you don't really need to write that 0. And that's equal to 8 minus 13, which is negative 5. So let's write that result just a little bit clearer. That resulting equation is just 5x equals negative 5, which is a pretty simple solve. We're going to divide both sides by 5 and get x equals negative 1. Now I'm going to pick one of those two original equations. I'm going to find which one looks easiest to me. And you may feel differently, but I think that first one looks easiest. So I'll start off with 2x minus 5y equals 8. I notice that x is equal to negative 1 from my previous work, so I can substitute negative 1 for x. From here we just do some algebra solving, so 2 times negative 1 is negative 2, so negative 2 minus 5y. Add 2 to both sides. That gives me negative 5y equals 10. Then we'll divide both sides by negative 5, which gives me y equals negative 2. So the answer should be negative 1, negative 2. Looking at the graph of the two equations confirms my result, so my solution should be negative 1, negative 2. For level 2 of the same type of problem, we notice that there are no zero pairs right off the bat. I've got 8x and 7x, that's not a zero pair. I've got 4y and 3y, and that's not a zero pair either. So I'm going to have to do something in order to get a zero pair. This is where you have to do a little bit of thinking, and you have to decide which one of these two looks better. Better means more manageable numbers, and also sometimes I'm also looking for a positive and negative pair. So if I take a look at the x column, and I compare that with the y column, it looks like the numbers on the y's are more manageable. 4 and 3 feel more manageable than 8 and 7. So I'm going to basically switch the coefficients of y. So I'll multiply the bottom equation by 4 and the top equation by 3. Incidentally, whether or not the coefficients were positive and negative doesn't really matter. I'm going to start off by multiplying by positive numbers only. And then I notice that both of the two coefficients are positive. We've got positive 4 and positive 3. And since they're both the same sign, I'm going to have to switch one of them. That's my signal to multiply the second equation by negative 4 instead of positive 4. We're going to distribute the 3, and then we're going to distribute the negative 4. Now that I have it all distributed, I'm going to look at those columns again. And I notice that I've got a zero pair with the y's now. And this was the whole point of the multiplication. We wanted to create a zero pair in either the x's or the y's. So now we can just add things together, just like we did with the level 1 problem. So I've got 24x minus 28x. That's negative 4x. 12y and negative 12y make a zero pair, which you don't need to write. And then 36 minus 40 is just negative 4. With this new equation, we're going to divide both sides by negative 4, and x equals 1. Once I have x equals negative 1, I've solved for one of the variables. I need to go back to the original equations and try to decide which one of those two looks easiest. And I'm guessing the first one probably looks a little bit easier. So I'll just use that first equation. If you feel like the second equation is easier, go ahead and use the second equation. It's not going to hurt anything. Since x equals 1, I can substitute 1 every time I see x. And this gives me 8 plus 4y equals 12. Subtract 8 from both sides. This gives us 4y equals 4, which is the same thing as saying y equals 1. I'm not going to bother dividing on this one. If 4y equals 4, then clearly y has to equal 1. Which means my solution is 1, 1. We can confirm this solution again just by graphing and seeing that the intersection point is 1, 1. Now for the level 3 problems, we're going to notice that the first equation is not in standard form, which remember that was ax plus by equals c. And also that second equation isn't in standard form, ax plus by equals c. So in order to solve this, I'm going to have to get both of these equations in standard form to begin with. Let's start off with that first equation. Notice how this plus 4y is on the wrong side of the equal sign. So I'm going to subtract a 4y from both sides. That creates a zero pair on the right side of the equal sign and simplifies everything into negative 4x minus 4y equals negative 2. With the second equation, this minus 4x is in the wrong place, so I need to move that over to the left side of the equal sign. This time I add 4x to both sides. That gets me a zero pair on the right side, and that simplifies to 4x minus 4y equals 1. Let's write those two equations next to each other, and let's see if we have a zero pair already. And it looks like the x's already form a zero pair, so I'm not going to worry about multiplying both equations like we did in the level 2 problem. I'm just going to add the two equations together. So negative 4x plus a 4x, that's a 0, which of course you don't need to write. And then we got negative 4y minus 4y, that's minus 8y. And then I have negative 2 plus 1, and that's going to be equal to negative 1. We'll divide both sides by 8, negative 8. That gives me y equals 1/8. Looking back at the original equations, I want to figure out which one of those two looks easiest. And I'm thinking that the second one looks easiest, or at least I'm guessing that's what a lot of you would pick, because you see a positive 1, and in the first equation you got a negative 4, a negative 2, and a positive 4. Well, actually, I don't know. Maybe that first one will be easier. Let's pick the first one. We'll just write this down over here on the right. From my work, I already know that y is equal to 1/8. And here's a y, so I'm going to substitute that 1/8. That gives me negative 4x equals negative 2 plus 1/2. 4 multiplied by 1/8, or 4 divided by 8 is 1/2. Minus 2 plus 1/2 is negative 3/2. Divide both sides by negative 4, and x is equal to 3/8. This means my solution is 3/8 and 1/8. And this solution is verified using the graph. So there you have it, 3 different levels of elimination method for solving a system of linear equations. Hopefully that's helpful to you, and good luck. Enjoy your algebra.